review some logarithm, thing that we spent time with before, but we just want to make sure we hone those skills today. So now when we're talking about logarithms, we're really also talking about exponential. It is super important that we understand the form of an exponential. For example, if I have a to the b equals c, this is an exponential as long as a is greater than 0, or in other words, a is non-negative, and as long as a is not equal to 1. Why might that be? Well, think about if a was 1, anything to the one, any power is just going to be 1, so we want that to not be. Now, you can convert an exponential to a logarithm. Remember that if a is the base of this exponential, then a is also going to be the base of the log. So I have log base a of c equals c. Now, the conversion here can be very useful when we are solving log equations. You know, we also like to understand their graphs. Lead me to our next thing. So, graphs. Start with the graph of an exponential, a to the x. So, shape of the graph, you do notice that it does show exponential growth in this one. You know, all of a sudden we're very flat, and then we get increasing by a lot. There are two very important order pairs on this graph. We have order pair 0, 1, and we have order pair 1, comma, a. Now, that based on the base. Also, just to keep in mind that these order pairs can change if there is some kind of transformation done to the equation, whether that's a horizontal or vertical shift, or maybe that's a shrink. Now, let's talk about the equation of a log and how we could graph that. Now, this graph takes kind of right here. Notice that it does keep going down forever, so on our graphing calculator, it'll stop. It didn't actually stop. It's just your graphing calculator can't do everything perfectly, and it can't draw vertical lines. Now, some important order pairs on this graph, point right here is order pair 1, 0. And there would be another order pair on here, base, comma, 1. Again, same thing before. These could change if there's kind of transformation done to the equation, but just some parent points for us to keep in mind. Another thing to keep in mind is look at the comparison of these ordered pairs. You'll notice it's kind of like they're just flipped. So that relates directly to what's so special about exponentials and logs, and it's that they are inverses of each other. Talk about change base. Base can be really useful, especially when we're using our calculator. So, when we have a log with some kind of base, a of b, log base a of b. Now, if this common log, remember common log is base of 10, we have the natural log, which is base of b. If not one of those two things, change base could be useful in terms of plugging the for calculator. It's the same thing as having log base c of b over log base c of a. Notice that both of these changed. Any random number to c, this would be an integer, and we could type this in. Now, a lot of times we'd probably make c be 10 for common log, right? So for example, let's actually take a look at our calculator. Let's say I want to know, like, what's the value of log base 2? Let's write this down. What's the value of log base 2 of 5? Now, I'm looking at my calculator, and I don't necessarily see, like, log base button. We'll show you in a second how you can do that. But I can use common log. So log, instead of c, it's going to be 10. So log of 5 divided by log of 2. That would be my value. Now, I did mention there is a way on some of the newer calculators to change that base. If I go to math, scroll all the way down, and I see something called log base. Just enter here. Notice that allows me to to have a base that's not 10 or b, and I get the same value. So just things to keep in mind there. You can also use that in terms of graphing. So, for example, let's say I wanted to have log base 3 of x graphed. I could do that, or I could do, the x for an exponential. Some things to keep in mind with properties. I love properties of logs and exponentials. Well, I guess really logs, but I also am a math teacher, so that kind of makes. We like properties when we are solving equations. A product. Log base a of x times y. Yes, I could have just written that as y, but I want to really emphasize that this is a product. I can sum of logs be the same thing as log base a of x plus log base a of y. Similarly, we have sense of logs. Let's say this time I have x over y. I have this division. So I can rewrite this as log. So log a of x minus log a of y. Now, a lot of times students often forget, like, okay, well, which one am I subtracting from which? So just remember that the numerator is listed first in this difference. Okay. Another one, we have a power rule. So let's say I have log base a of x to the b power. Okay. One thing that we can do with this exponent is that we can multiply in the front of the log. So that would become b times log base a of x. Now I don't have any exponents here. So before I conclude, I would like to give you just two challenging problems, but why not? At least. So one would look and try this. Expand log base 3 of 4x squared over square root of 5. And if you can do that, why don't you try to turn the following 3 log base a of x minus parentheses log base a of y plus 4 log base a of z. Hope you can read that. Try those. Again, I'm just trying to challenge you and really just try to draw that prior knowledge. So go ahead, try that. Unpause me and we'll check.